So, hello everyone. I hope you are doing well. Let's start today talking about the soil classification according to soil taxonomy at orders level. Okay, so we already saw all the diagnostic horizons, all the app patterns, and then we have enough knowledge to talk about soil classification. Okay, so let's start. As you should remind, the soil taxonomy, it's one of the systems that plans to classify and describe soil around the world. And in soil taxonomy, we have 12 orders. The orders are the highest levels in this, the highest level in the soil taxonomy, and these orders, they are related to the minimum detail information that we have about the soils. Okay, so we have a general classification that express the soil formation and basically the main process related to the soil formation and the main morphological, chemical, and physical properties. But of course, each of these orders, they host different soils with different properties and also different characteristics, but they have at least some morphological, physical, and chemical properties that are quite common. Okay, so to classify a soil at order level, you need to combine the app pattern and the subsurface diagnostic horizon, and in some cases also combine some diagnostic characteristics. Okay, so we will see that for some orders the app patterns are not important, the diagnostic characteristics are not so important, but the subsurface diagnostic horizons, they are important. But the others, yes, we also need a pattern, and for others we also need the diagnostic characteristics. So each order will have the specific criteria that we need to follow. As the diagnostic horizons, these orders, they have specific criteria, specific rules that should be followed, and according to this criteria, according to these rules, we can classify the soils. Something that's also quite important to mention now is that the soil classification according to soil taxonomy should follow a specific order, a specific list that it's presented in this specific slide. So every time that you will classify a soil, you need first think on jelly soils, and then in histosols, and then in spodosols, and go down. Okay, so when you go to classify a soil, you need to follow this specific list. You shouldn't start, for example, from alpha soils or iridosols. You need to exclude these orders first to think in the other orders. Okay, so for example, let's think that I'm the field and I described the soil and I identify which diagnostic horizons and which app patterns I could find in that specific soil profile. And now my plan is to classify the soil. Great. The first order that should be on my mind, should pop up on my mind, is the jelly soils. So I need to check to stand that specific soil and think, okay, can you be a jelly soil? And I will check the criteria and say, no, unhappily, you cannot be a jelly soil. Okay, great. So let's think about the histosols. Can be this specific soil profile that I'm standing. It can be a histosol. No, cannot be a histosol. So great, I will go to the 30th place, the spodosols. Can be this specific soil profile a spodosol? Yes, it can be a spodosol. So great, I just finished the classification considering that that specific soil profile fits the criteria for the spodosols. Okay, so you must follow this specific list, this specific order. Something that's quite interesting and nice is that you can see this order several times in the soil taxonomy, so it's quite hard that someone forgot to consider it. But yes, you need to worry about it. Okay, you need to worry and be sure that you are following this specific list. Why should we do that, JJ? Because, for example, some soils, they could fit the criteria for Antisol, but actually it fits the criteria for example, an Aridisol first. So if it fits the criteria for one of these highest orders in the highest levels in the beginning of the list, so you need to classify it as one of these orders in the beginning of the list. Okay, so we prepare a list according to the land use potential and the problems and the potentials that the soil can have. So we consider that these names in the beginning of the list, they are, let's say, more important, or at least they could be more problematic, or they could create any other problem, physical or chemical problem, or they have a very high potential. So we also consider that they need to be classified. So when you start the list, as soon as that specific soil profile fits all the criteria to be classified as one of these orders, it should be classified as that specific order. Okay, so you should follow this list always. So keep it on mind. Let's start with something that's quite easy, the jelly soils. The jelly soils are the first order in that list, and the jelly soils are soils with permafrost in the first 100 centimeters below the soil surface. And we already know what is permafrost. Permafrost is a thermal regime. They are connected to a layer that presents very low temperatures equal or below 0 Celsius degree for 2 consecutive years. So you need to register the soil temperature for a long time to be sure that you can classify a layer as a permafrost. And if this permafrost is in the first 100 centimeters below the soil surface, yes, you can classify that soil as a jelly soil. Oh, JJ, but this specific soil has a very reddish color. No problem, it's a jelly soil. Oh, JJ, but this soil profile has a very high organic carbon content. No problem. Since you fit one of these two options, that specific soil must be classified as a jelly soil. Okay, so we have here the word or. So if a soil profile has a permafrost in the first 100 centimeters, it should be classified as a jelly soil. Or if the soil presents gelic materials in the first 100 centimeters below the soil surface, and the permafrost is present in the first 200 centimeters of the soil surface. So if you present some evidence of cryoturbation, the morphological evidence of cryoturbation, it's called gelic materials. So if you have some morphological evidence of cryoturbation in the first 1 meter, and the permafrost can be found up to the first 2 meters below the soil surface, so yes, you also can call that soil as a jelly soil. So you need to fit one of these two options to classify a soil as a jelly soil. And as I said, any soil profile, all the soil profiles that fit one of these two options, it should be classified as a jelly soil, okay? Because it's the first order, is on the top of the list. Oh, so let's think a little bit about these gelic materials, just to be sure that everyone can understand. The gelic materials, as I said, they are morphological evidence, morphological features that express cryoturbation. And this kind of wavy and irregular or even broken horizons, as you can see here with these U-shaped horizons, they express the cryoturbation. As I said, cryoturbation is that specific process that induces clay migration from the bottom to the top because of the difference of temperature between the soil surface and the permafrost. Okay, so we also can see some spots of organic material like this dark spots in the soil expressing the cryoturbation and the mixing of material from different horizons. We also, of course, can see the permafrost by itself, like here, okay? And I already show you that sometimes we'll have some water, some W layers above the permafrost because water cannot penetrate through the permafrost. And in these areas, we have a very intense cryoturbation that could produce some partner ground, as you can see here. And when you check some samples, you can see this clay materials, this clay links between the surface and subsurface horizons, okay? When we check these materials at the microscope, we can see some vesicular voids and some features that also express the cryoturbation, the mixing of materials from different horizons, and of course, the clay migration from the bottom to the top. We also can see some cracks in the materials formed by frost desiccation. It's quite common also to see on the borders of the grain courses, the sand courses and the gravels, that you have some dark material because of the clay that's attached, that's coating this coarse grains. Okay, you can see in both pictures that on the border we always have this darker color. Here you also can see the partner ground, and because of the vegetation it's even easier to see them. And we also can also register some partner ground as some stripples, as you can see here. So these stripples, they also express the evidence of cryoturbation and the evidence of geolic materials, okay? So again, just to be sure that everyone understood, geosols, they should present the permafrost in the first 100 centimeters below the soil surface, or geolic materials plus permafrost, and they should fit these specific depths, okay? So any kind of soil that present the permafrost and maybe the geolic materials could be, should be, must be classified as a geosol, okay? So great, quite easy. We just need to monitor the soil temperature, and then we can call one specific soil as a geosol, okay? So, okay, great. Let's see the histosols now. The histosols are soils that they don't fit the criteria to be classified as a geosol. So they don't fit the two first criteria that identify the geosols. So if I cannot classify a soil as a geosol, so then I will think, okay, maybe this specific soil profile can be classified as a histosol. And for that, I will check, okay, which are the criteria for the histosols? First of all, to be a histosol, that specific soil do not have an index soil property in the 60% or more of the thickness between the soil surface and either a depth of 60 centimeters or a densic, lithic, or paralithic contact, or a duripan if they are shallower than 60 centimeters. Okay, so I need to consider a specific thickness, for example, 60 centimeters, or the contact between the soil surface and the densec, lithic, porolithic contact, or even a deripam. And in this specific section, I should register a very low content of indic soil properties. The indic soil properties, you should remember, are those diagnostic characteristics that express the presence of allophane, immogolite, and low crystalline minerals that are connected to tuffs and volcanic glass and materials that came from recent volcanic activity. Okay, so the histosols, they should present very low content of indic soil properties, or even no content of indic soil properties. If one specific soil has a very high content of soil that express indic soil properties, so I cannot call it as a histosols. Okay, so as histosols, I'm sorry. So and you can see here that that specific soil should register high content of organic carbon. This high organic carbon should be present in some of these places. So it should register organic soil materials that meet one or more of the following. Okay, so I have some letters here that should fit. Organic soil materials, you should remember, is the content of 12% of organic carbon. So I should register layers, or at least one layer with at least 12% of organic carbon. And this organic carbon this very high organic carbon layer should overlay any other kind of material, organic material, in different stages of weathering, like these pumiceous or fragmental materials, and they should fill their interstices, the voids or the pores, and directly or below some materials as densec, lithic, or porolithic contact, or when added with the underlying cindery, fragmental, or pumiceous materials, organic materials with different stages of decomposition. They should fit 40 centimeters or more between the soil surface and a depth of 50 centimeters. Okay, so you need to register our high thickness of organic materials, and organic materials could be registered at different stages of weathering, of decomposition. Okay, the other option is that this organic matter, this organic soil, this layer with at least 12% of organic carbon should constitute 2/3 or more of the total thickness of the soil to a densec, lithic, or porolithic contact, and have no mineral horizons, or have mineral horizons with a total thickness of 10 centimeters or less. So if that specific soil register one or other horizons or layers with less than 12% of organic carbon, these horizons, these layers, they should register less than 10 centimeters or less of thickness. Okay, just to avoid that we have a very high mineral contribution to the soil properties in that specific soil. Okay, and the other option is that we have a saturated soil, and this saturation, it fits 30 days or even more in normal years, or the soil, it was artificially drained in the past, and it has an upper boundary in the first 40 centimeters below the soil surface, and have a total thickness of 60 centimeters if this material is composed basically by moss fibers and has a very low bulk density, or 40 centimeters if it's composed by materials with a higher stage of decomposition and or present a higher density. So in saturated histosols, we have two options of minimum thickness: 60 or 40 centimeters, according to the density, according to the which kind of organic matter can I find in that specific soil profile. I can find only very low low decomposed organic material, very low density, so at least 60 centimeters. If the stage of wafering, of the composition of this organic material, it's higher, so 40 centimeters it's enough. 40 centimeters or more than this, and I can call that soil as a histosol. Okay, so you can see here some pictures. Those soils with a very huge contribution of organic carbon. As I said, a very high organic carbon content in this soil, showing that yes, this specific soil express very high organic carbon content, and this organic carbon content, it's inducing, controlling all the morphological, physical, and chemical soil properties. You can see here the same, and all of those soils that fit one of those criteria, it could be called as a histosol. If I don't have all of those criteria fitted, so I can think, okay, maybe this soil could be a spodosol. And the spodosols, they are those soils that register spodec horizons. And the spodec horizons, you should remember, are those soils that has spodec materials. And the spodec materials are those materials that express migration of organic matter and or aluminum and iron oxides. So they migrate from the upper horizons, from the topsoil, from the apaton, and they concentrate at subsurface horizon. That's called spodec horizon. Okay, so you can see in this specific photo that we have here an apaton, an E horizon. We have an E horizon, and this E horizon has a very light color, like a very intense white color. And below of it, we have a spodec horizon with a concentration of organic material. And below of it, we can also find another spodec material, but now with a reddish, yellowish colors, expressing also concentration of iron oxides. So this is a very good example of spodosols because it presents this spodec horizon. These also are examples of spodosols. I think that I already show you all of these pictures. We have above the topsoil, the apaton, then the E horizon, and then the spodec horizon here. Some of these spodec horizons, they present a darkish color with the concentration of organic carbon. Some of them present a yellowish color, more related, more connected to iron oxides. Here it's basic the same. And let's see the required criteria to call a soil as a spodosol. The spodosols are soils that cannot be classified as a gedisol or cannot be classified as a histosol, and they don't have a Pelagian apaton. The Pelagian apaton is that horizon induced by humans, that are the humans, they bring material to these specific soils, okay, trying to increase the soil fertility, and they bring some sandy materials in sometimes, and because of this we have a mix between what could be an E horizon and what was induced or transported by humans. And these spodosols, they don't also register an argillic or candic horizons above a spodec horizon. So I cannot find a spodosol with an argillic horizon above an spodec horizon, or a candic horizon above a spodec horizon. Okay, if I found an argillic horizon or a candic horizon, they should be below this spodec horizons. Okay, and these soils, they have one or more of the following criteria. Okay, they have a spodec horizon, an albic horizon in 50% or more of each pattern, and they register acrylic or gelic soil temperature regimes, very low temperature, okay, very, very low. They could be found in areas with permafrost, but of course, to classify a soil as a spodosol, it should not register a permafrost. So very low temperatures, very, very low temperatures, sometimes even temperatures below 0 Celsius degree, but air temperatures below 0 Celsius degree. Okay, if the soil register a layer with temperatures below 0 Celsius degree for 2 consecutive years, so I cannot call that soil as a spodosol. Okay, another option to classify a soil as a spodosol is that I register an AP horizon containing 80%, 85% or more of spodec materials. Okay, so I have an A horizon, a surface horizon that express a very high content of spodec materials, materials that express a high concentration of organic matter and or aluminum and iron oxides. Another option is that I found an spodec horizon with all of the following characteristics. Okay, this spodec horizon should present a minimum thickness of 10 centimeters or more. So minimum thickness of 10 centimeters. It should register an overlying AP horizon or a cementation in 50% or more of each pattern, or a textural class that's finer than coarse sand, sand, fine sand, loam coarse sand, loamy sand, or loam fine sand in the fine earth fraction, and a frigid temperature regime. So I should register something that does not register a sandy texture and present very low temperatures, and acrylic or gelic temperature regimes in the soil. Okay, so I at least fit one of these options in the A, or I need to fit the B and the C. Okay, so an upper boundary within the following depths from the mineral soil surface, either less than 50 centimeters or less than 200 centimeters if the soil has a textural class of coarse sand, sand, fine sand, loamy, coarse sand, loam sand, or loam fine sand in the fine earth fraction in some horizon between the mineral soil surface and the spodec horizon. So I should register the spodec material in the first 50 centimeters or 200 centimeters if I register a sandy texture. Okay, I should fit one of these two options. I also should fit one of these options, in this case, a lower boundary as follows: either at a depth of 25 centimeters or more below the mineral soil surface, or at the top of a duripan or fragipan, or at a densic, lithic, porolithic, or petroferric contact, whichever is shallowest. So I should register a depth that fits one of these options. Okay, at any depth I can register if the spodec horizon has a textural class that's finer than coarse sand, sand, fine sand, loam coarse sand, loamy sand, or loam fine sand in the fine earth fraction, and the soil has a frigid temperature soil regime, or if the soil has a acrylic or gelic soil temperature regime. And letter D, either I need to fit also one of this: a directly overlying albic horizon in 50% or more of each pattern. So I should find an albic horizon, or no endic soil property in 60% or more of the thickness. So I cannot find those properties that are connected to allophane, immogolite, and a very high absorption of aluminum and iron by the organic carbon. Okay, the organic matter. So in the first 60 centimeters, either the mineral soil surface or the top of an organic layer with endec soil properties, whichever is shallow. If there is no densec, lithic, or paralithic contact, a duripan, a petrocalcic horizon within that depth, so in this first 60 centimeters, or between either the mineral soil surface or the top of an organic layer with endec soil properties, whichever is shallower, and a densec, lithic, or paralithic contact, a duripan, or a petrocalcic horizon. So I cannot register endec soil properties in 60% or more between the soil surface and these horizons, or this organic layer and these horizons, okay? And so we are talking about a lot of these endec properties, and these endec properties now pop ups as the Andes soils, the soils which register endec properties, the soils that are connected, directly connected to recent volcanic activity. And the Andes soils, they present endec properties, and they present the melanic pattern. So this is the first order that you can see that the classification is connected to the pattern. So to call something as an Andes soil, you need to find the melanic pattern, and you need to find endec properties. So I don't register one specific diagnostic horizon at the subsurface, but definitely I find endec properties, one of the diagnostic characteristics that are connected to the soil taxonomy. And also I need to find the melanic pattern, one of the patterns that we use to soil classification according to soil taxonomy. As we already said, the Andes soils, they are connected to allophane, immogolite, and other low crystalline minerals, okay? And they present a very high affinity between aluminium, iron, and soil organic carbon, okay? You already saw also these pictures showing that we have these very dark horizons with the melanic pattern, and sometimes with this reddish or whitish color, these horizons with endec properties that are not the melanic pattern. They are other kind of horizons, subsurface horizons, which present the endec properties, okay? And to classify a soil as an Andes soil, I need that specific soil profile cannot be called, cannot be classified as a jelly soil, cannot be classified as a histosol, cannot be classified as a podosol, and then this soil register endec soil properties in 60% or more of the soil in the thickness. That we have two options now. The first option is that you need to find these endec soil properties in the first 60 centimeters between the soil surface or atop of an organic layer with endec soil properties, and the densec, lithic, paralithic contact, a duripan, or a petrocalcic horizon, okay? And and the other option is that I found a horizon or a layer with endec soil properties between the mineral soil surface or the top of an organic layer with endec soil properties, and a densec, lithic, or paralithic contact, a duripan, or a petrocalcic horizon, okay? So I need to find basically endec properties. I need to find an expression of an intense presence of immogolite, allophane, and these kind of minerals, low crystalline minerals, okay? And the oxysols, they are the opposite of the endosols. When I talk about oxysols, I need to think in very intense and strong chemical warping and leaching. So when we talk about endosols, we are talking about horizons and layers in soils that are formed by recent volcanic activity and a very low warping and leaching, at least a moderate wafering and leaching. But the oxysols, this wafering, it's quite intense, it's quite deep. So to form an oxysol, I need to think about a parent material that was wafered and leached by intense tropical climate conditions, wet and hot climate conditions that destroy basically all the primary minerals and concentrated now iron oxides and some silicates, but especially one-to-one minerals, those minerals that are more resistant against the wafering. Okay, these oxysols, they also present a very intense biological activity that create this kind of very diffuse transition between the horizons with a very similar color between the horizons because of the bioturbation mixing particles, organic and mineral particles from different depths in the specific soil profile. So we can see here an oxysoil with a reddish, very strong reddish color. You can see here one of a yellowish color. This specific soil profile has more than 6 meters of thickness, but it's quite common that oxysols, they can achieve much more than 40-50 meters. Okay, so they are really thick soils, and sometimes they also can present some iron cemented layers among these horizons and layers. It's quite common to see this kind of horizons and layers that we call it as petroferric contact, and these specific materials, they are more connected to an intense wafering and then cementation of soil by iron oxides. So especially hematite, it could cement some parts and some layers of the soil and create the cemented layers. Okay, sometimes these particles cemented by soil, they are not intensively connected and they can be widespread around the soil profile, as you can see here. This is the same, another soil profile with a lot of gravels, but these gravels are not rock fragments, they are basically soil cemented by iron oxides. And the required criteria to classify as an oxysol is that that specific soil, it not fits the criteria for a jelly sol, it does not fit the criteria for a histosol, not for a spodosol, not for an andesol, and now it registered an oxic horizon in the first 150 centimeters below the soil surface, and I cannot find a candic horizon in this first 150 centimeters. Okay, so I should register one specific subsurface diagnostic horizon. I should register the oxic horizon in the first 150, or I should register 40% or more by weight of clay in the fine earth fraction between the mineral soil surface and a depth of 18 centimeters after mixing, and a candic horizon that has the waferable mineral properties of an oxic horizon and has its upper boundary in the first 100 centimeters below the soil surface. So some oxysols, they could register a candic horizon as soon as this candic horizon has properties connected to the oxic horizon. And JJ, I cannot remember very well these properties of the oxic horizon. Well, it's quite easy. This oxic horizon, it's that horizon that presents a very intense chemical wafering. So it's basically composed by kaolinite, halloysite, and other minerals that are one-to-one minerals, and also iron oxides, gibbsite, manganese oxides that are concentrated by an intense chemical wafering. Okay, so soils that register wafferable minerals properties that express an intense wafering and leaching could be connected to an oxysoil. Okay, and we can now see other options, other order that's again the opposite, the vertisols. The vertisols is the opposite of the oxysols because the vertisols are also very low waffered minerals, waffered soils. These soils, they register very low wafering and destruction of the primary minerals. It's quite common also to present 2-to-1 minerals that could shrink and swelling very easily according to the moisture content. Okay, so the vertisols are those soils that present vertic properties. These vertisols, they are not connected specifically to one specific horizon. So I cannot find like a vertic horizon. No, I will find vertic properties, properties that express a high content of clay, and these clays, they register high activity. So they are 2-to-1 minerals that they can easily shrinking and swelling according to the moisture content. It's quite common that vertisols also express some migration of clay from the bottom to the top, but this is not connected to differences of temperature between permafrost and the soil surface, but now they are connected to differences of temperature between the soil surface and the bottom of the soil, and also differences of moisture content. Sometimes the moisture content is much higher at the bottom and quite low at the surface, the soil surface. So the water can migrate from the bottom to the top against the gravity and also bring some clay, as you can see in this picture. So this kind of plume of clay comes from the bottom to the top, in direction to the top, because of the difference of moisture content and also differences of soil temperature. It's quite common in the vertisols that we can see some of these cracks as an expression of the vertic properties, cracks that are formed by shrinking of soil during the dry season. And it's quite easy to see the shrinking and the cracks here. Here you can see the size of these cracks. They are huge, quite huge. And also we can see some specific structures that are more connected to high activity clays, like the angular blocky structures. I'm sorry I broke this part, but you can see very easily here how sharp are these edges, and that they form angles of 90 degrees. Okay, it's also quite common to see the V-shaped structure and prismatic structures. These wedge or V-shaped structures, they are quite common in vertisols, and they are connected to 2-to-1 minerals. Okay, and also it's quite easy to find slickensides. The slickensides, they are these shiny faces that are formed on the top of some aggregates, some pads, and they are formed by this friction between one aggregate and the other. Because of the action of shrinking and swelling of the aggregates, because of the change of moisture, during this shrinking, they can frictionate one aggregate, one pad against the other, and this friction can create this shiny face. Okay, and this shiny face, you also can see some lines here that express the friction of these aggregates, and because of this we know that they are not clay skins, okay, but they are connected by they are created by this shrinking and swelling and the friction between aggregates, between pads. The required characteristics to call a soil as a virtuous soil is that, first of all, that specific soil cannot fit one of the criteria for the others. So it's not a jelly soil, it's not a histosol, it's not a spodosol, it's not an andesol, it's not oxysol, and it should register a layer with 25 centimeters or more of thickness in the first 100 centimeters below the soil surface, that has either slickened sides, those shiny faces that I showed, or wedge-shaped pads, these V-shaped pads that I already showed, with angle tightened between 10 to 60 degrees from the horizontal plane, and an weighted average of 30% or more of clay in the fine earth fraction, either between the mineral soil surface and a depth of 18 centimeters, or in an AP horizon, whichever is thicker, and 30% or more of clay in the fine earth fraction in all horizons between a depth of 18 centimeters and either a depth of 50 centimeters, or a density lithic or a paralithic contact, a duripan or a petrocalcic horizon. Okay, so I should register a high content of clay. You can think on this way. Okay, why? We are talking about a horizon, a soil that express a very intense shrinking and swelling of high activity clays. So if the content of clay is quite low, it's less than 30%, so means that maybe these clays, they don't express and control the morphology and physical and chemical properties of the soil. So we need to consider a high content of clay, at least 30%. And the last characteristic is that that specific soil should present cracks. And these cracks, they should open and close according to the season, according to the moisture content in the soil. Okay? So, okay, I think that I will avoid to continues because, of course, without your questions, it's a lot of information and I am moving quite easy and fast. Maybe we should stop here and continues with the aerosols before the next class. Okay, so I will start, and on the next class on Monday we'll see the rest of these orders, so we also can talk about eventual questions that you have about the others. Okay, so let's stop here, and please guys, read about these orders in the soil taxonomy, and you can bring more questions to the class and we can talk about the environment and the properties of each of these orders. Okay, so see you Monday. Thank you very much.